For a population that is left skewed with a mean of 29 and a standard deviation equal to 22, determine the probability of observing a sample of 28 or more for a sample size of 31. Okay, so I have written down all of our information. Now, our population is left skewed, but the central limit theorem is applied here because in cases where the sample size is 30 or larger, our sample size is 31, the sample means will be normally distributed regardless of the shape of the population distribution. So, we can use the central limit theorem there. And for any population, the average value of all possible sample means computed from random samples of a given size from the population is equal to the population mean. So we know the population mean is 29. And so it's going to be the mean of the sample means is going to equal 29 as well because of the central limit theorem. Alright, so before we can calculate the z value, we have to calculate the standard error of the mean, which is the standard deviation divided by the square root of n. The standard deviation is 22, the square root of n, which is 31. So we're going to calculate that round to 2 decimal places. That is 3.95. Now we're ready to go back and calculate the z score for the sample mean, which is equal to the sample mean, and we're looking at 28 here, x bar, minus the mean of the sample means, which we just talked about, is 29. So our value is to the left of the mean of the sample mean. So it's going to be a negative z-score, divided by the standard error of the mean, which we just calculated. So we're going to get this value and round it to 2 decimal places. That gives us negative 0.25. We're ready to look it up on the table. So now here's negative 0.20. 21, 22, 23, 24, 25. So 0.4013. And that is less than or equal to 28. Or if you want to write it as a z, less than or equal to negative 0.25. Now, let's think about this, and we have talked about this before. This is a normal distribution because of the empirical rule. And this is the mean, and this is the value that we're looking at, and we looked it up on the table. It gave us the probability that x, the sample mean, is less than or equal to 28. So when we looked that up, we got 0.4013. But I actually want the other side, the greater than side. And the rule is, if you want the greater than side, the table's always going to give you the less than or equal to side. Okay, so if I want the probability of the greater than side, I know that the total probability is 1. So I'm going to take 1 and subtract out the side I don't want, and that will give me the side that I want. This is called the complement rule. So when you do 1 minus 0.4013, you get 0.5987. So 0.5987 is one of the correct answers here that is acceptable.